Supplements can do a lot of good for your health, but I've noticed a tendency to promote the more expensive supplements, even when they don't really make any sense. A good example is organic grass-fed collagen, which is very expensive. The truth is, collagen has to be broken down to be absorbed, and most of the amino acids comprising collagen are common in the body and do not require supplementation. The only one that is really lacking in most people's diet is glycine, which is dirt cheap. When you take expensive collagen supplements, what's really being supplemented is the pocketbook of whoever's selling it to you.
He's pretty good.
Good. He's the best.
You'll actually produce more collagen by taking glycine than you'll get by taking collagen itself. It's also much more easy to get down. It's about the same consistency and taste as sugar, just not quite so sweet and cloying. And before anyone asks, no, you can't take gelatin as a cheap alternative. Unless it's grass-fed beef gelatin, which is very expensive, it will be full of glyphosate. And glyphosate is very similar in structure to glycine. That's why it presents such a problem in the body. I talk about this in great detail in one of my previous videos that you might want to go back and watch. NMN is another supplement that is expensive and could be easily replaced. NMN increases NAD+, which is required for your cells to repair the damage of aging by triggering the sirtuin genes.
The lesson was that these sirtuin enzymes that were controlling genes were also controlling lifespan, which was a real breakthrough. No one had really expected to find gene regulators controlling aging. We thought we'd find antioxidant producers and DNA repair proteins. That's not what we found, not initially. And so the sirtuins became very interesting in yeast, and Matt Kaberlein, who's now out in Seattle, who's a leader in the field as well, he came in and his first project in the lab was to put an extra copy of one of the SIR genes, number 2, SIR2, into yeast, and those yeast lived 30% longer. And later, Lenny's lab and my lab at Harvard showed that this was through a process of mimicking calorie restriction.
When I first bought it, it was about $1,500 per kilogram. It's gone down in price, but still typically costs around $1,000 per kilogram from reputable sources. By far the most expensive supplement I have ever tried, and I had to wonder even at the time why I was paying such ridiculous prices. In reality, this is just an expensive and vastly overhyped form of niacin. In studies, 250 milligrams of niacin given to seniors shows a similar uptick to their health as NMN. The only real benefit here is to provide a no-flush version of niacin that doesn't excessively damage your liver. The magic trick NMN and niacin accomplish is to provide more NAD+ to cells, which tend to become depleted over time. This can make you a bit more energetic on the level of the cell itself. People often think more clearly and generally feel more peppy. However, there are other ways to do this which are possibly better, and sometimes even free. Taurine, for example, also boosts NAD+. In fact, it does so in a better manner, which seems to upregulate the NAD+ salvage pathway. This also reduces NADH at the same time, which tends to clog up your cells as you age. In fact, taurine helps you with every single step of the energy production process because it's vital for cell membranes to properly take up or keep out energy production substrate and the byproducts of energy production. This means your mitochondria will burn much more cleanly and produce far fewer harmful byproducts. No doubt this is why taurine has been shown to have strong anti-aging effects, and there's many animal studies to prove this. Fasting is free, and it also helps a great deal with the NAD+ situation in your cells. The root cause of this problem is actually in pathogenic gut bacteria. Your immune system wages a constant war against intruders trying to enter your body through the gut, And as you age, this takes up more and more of the body's resources. This includes NAD+, which is used up quickly by macrophages when they are stuck constantly in the pathogen-fighting mode. And this is mainly from trying to fight off gut bacteria which infiltrate the body. This is the reason your cells run out of NAD+ in the first place, and fasting can help with this a great deal.
So what I'm going to be showing you today is one way to think of how some of these hallmarks of aging might be interacting together. And the focus of this presentation is on an observation that was made a number of years ago by many investigators, which is the fact that NAD levels decrease during aging. And this occurs in multiple tissues. It ranges from 20 to 50 to 80%, depending on the tissue, depending on the model system. During aging, we know there's increased DNA damage. This is obviously accelerated in patients who have deficient DNA damage repair, such as cocaine, xeroderma pigmentosum, or ataxia-telangiectasia. And so this leads to accelerated DNA damage and activation of the PARPs, which drains away the NAD so that the redox enzyme and the sirtuins actually do not have the proper amount. So this was one model. This model is now evolved, and the focus of my talk is going to be on another family of two proteins, CD38 and CD157, who are also NAD-consuming enzymes, NAD hydrolases. So our interest in these two enzymes was triggered by a paper by Camacho, Pereira, and Eduardo Chili at Mayo Clinic. What they reported in 2016 was the observation that CD38 levels increase quite significantly during aging. And in contrast, the other NAD-consuming enzyme, PARPs and SIRT1, NAMPT, which is actually in the salvage pathway, did not seem to vary. In what tissues, in what cells within adipose tissue is CD38 expressed? We find that in aged animal, these are 25 months old mice, there's an increased level of CD38 expression in a fraction that we identified as the macrophages. Followed up this analysis using a number of additional markers to try to identify which types of macrophages actually express CD38. There are two different types of macrophages. In most tissues, there is a resident macrophage, which is deposited early in life, in embryogenesis or in the first few days of life. And there are also bone marrow-derived macrophages, which continuously are produced within the bone marrow, circulate to peripheral tissue. These different macrophages have different biology, and therefore we can actually separate them using a set of markers. And what we found was actually quite interesting, because if we look at mice aging from 2 to 25 months, we find that the CD38 level increases actually close to 7-fold in the resident macrophages, but does not change in the non-resident macrophages. So the next question that I will spend a few minutes on, which is really key here, is our effort to try to understand what activates CD38 expression in aging macrophages. Now, we think of aging as an unbalanced act between damage and repair. Early in life, we know that damage is a constant. In most of us, the repair pathways are highly activated early in life and tend to degrade as we get older. So there are macrophages actually play a very unique role in the biology of damage, and in particular by their ability to recognize different forms of damage that are imposed on tissues. And this is illustrated here, especially the innate immunity, dendritic cells that are illustrated here in blue, and the macrophages in purple, contain a number of specific receptors that are able to recognize two forms of molecules called the PAMs and the DAMs. The PAMs are pathogen-associated molecular pattern. So these are molecules that are typically released by pathogens, whereas the DAMs are damage-associated molecular pattern signatures. These are molecules that are typically released by cells that are stressed or injured. And macrophages are able to recognize those, to activate specific signaling pathways, and to leading to the release of cytokines, chemokines, immune cell recruitments, inflammation, and tissue repair eventually. So our first question was, what are any of these PAMs and DAMs able to activate CD38 expression in macrophages? And so the experiment was done by isolating primary macrophages from mice, growing them in culture, and subjecting them to treatment with a variety of these PAMs and DAMs. And what emerged is actually a pretty striking picture. We were expecting the DAMs to do it, but we were surprised to find that these macrophages actually responded primarily to pathogen-associated molecular signatures. In particular, one of them drew our attention. This is LPS. This is lipopolysaccharide. This particular molecule, which is released by gram-negative bacteria, is actually one of the main triggers for the differentiation of macrophages into a unique form in the so-called M1 macrophages.
When you fast, these old and inefficient macrophages are killed off. The negative gut bacteria also die off when you stop adding in food, and this takes pressure off the immune system. It also helps with leaky gut, which can make this problem much worse. This allows the immune system and other cells to begin the process of repairing your body, including the damage of aging. This process also consumes a lot of NAD+, and that's why having low levels is a very big problem. Thankfully, fasting also upregulates the NAD+ salvage pathway, which converts NADH back to NAD+. This means not only are you turning on these much vaunted SIRT repair genes to a degree that's simply impossible without fasting, but it also increases your NAD+ levels at the same time. If you just take niacin or NMN, your NAD+ will go up a bit, but that does not guarantee the body will actually use it for repair. Once the fast is done, brand new macrophages and other immune bodies are produced. Up to 1/3 are regenerated every time you do a single 72-hour fast. Of course, fasting is hard and taking some powder is easy, but nothing stops you from doing both. Also keep in mind that NMN and niacin both raise uric acid and are hard on the liver. If you take them, you should definitely take betaine/TMG to protect your liver. This also protects the kidneys and is very important for general metabolic health, especially for those who suffer from gout. In fact, gout is more about metabolic health than diet, and more about the liver than the kidneys. If your liver is healthy and unburdened, then it won't produce byproducts that cause problems for the kidneys, and you probably just won't have to worry about gout. Vitamin K2 is another somewhat expensive supplement, though not as expensive as NMN. The point of K2 for most people is that it helps increase phagocytosis in the body. This is the process where plaques and other materials are cleaned up by the immune system and then put to use elsewhere in the body or else excreted. Taurine can stimulate phagocytosis a great deal more than vitamin K2. That doesn't mean the body doesn't need K2, but you're probably getting enough in the diet for your blood clotting needs anyway. What you really want it for is the phagocytosis, and taking taurine is going to have a much greater effect. And that will help you clear out those pesky spikes, whether they're natural or artificial in origin. Like NMN, NAC is also under threat of FDA ban. Originally marketed as a drug, NAC is simply the amino acid cysteine combined with acetate or vinegar. While all the research is done on NAC, in reality NAC quickly becomes vinegar and L-cysteine in the body. While vinegar is a useful supplement in its own right, you could easily just take the much cheaper cysteine and get even better results. That's because by weight, there's much more cysteine in pure cysteine than there is in NAC. As an amino acid common within the body, there's also no possibility of an FDA ban. Keep in mind too that like NMN, NAC is somewhat overrated, though not to the same degree. The main reason that people take it is so that they can produce more glutathione in the body. However, glycine is also required for this, and for most people, most of the time, this is the limiting factor in your production of glutathione. You're going to get much more use out of taking some glycine than you would out of taking some NAC. And nothing stops you from doing both, which will give you even more effect. In fact, glycine and NAC are often promoted together as Glynac, which is shown to have many positive benefits for health and aging prevention. Cysteine can also help with graying hair, hair loss, and thin nails. Part of this is due to enhanced glutathione production, but other mechanisms are believed to come into play as well. Cysteine, the oxidized form of cysteine, is crucial for hair growth and lends strength and fullness. Cysteine is more absorbable, however, and has more productive material pound for pound. So many hair formulas contain cysteine, while cysteine is seldom used. It's actually more expensive and less effective. Interestingly, taurine also has a protective effect on hair loss, so it can be substituted not just for NMN and K2, but in some sense for NAC as well. Two substances threatened by FDA ban, and another substance that's a bit on the expensive side. It's important to realize that taking cysteine will never increase homocysteine, which is a metabolite of methionine metabolism which has negative health consequences. Some vegans invoke homocysteine as a terrible health consequence of eating meat due to its methionine content. But is going vegan to prevent this really a good idea?
What do you think? It stinks!
The problem with this logic is that taurine is produced from homocysteine. If you don't eat meat, you won't have any taurine in the diet, and you won't have the needed methionine in the diet, so you can't even make the minimal amounts the body can produce in that manner. This is going to have grave health consequences and rapidly increase your body's aging on a cellular level. You may have noticed the word cysteine appears in homocysteine as well, and this is not a coincidence. Homocysteine is also where your body gets most of its cysteine substrate for the production of glutathione, which is the master antioxidant. That's why vegans are low in glutathione, but those on a keto diet are shown to have greatly elevated levels. It's hard to decide whether lowering your taurine or lowering your glutathione is a worse problem, but regardless, you absolutely, positively do not want to be low on either one, and this is why it's vital to have meat in the diet, because you simply can't get enough methionine any other way. So are we just stuck with this homocysteine byproduct that creeps up with age then? Thankfully that is not the case. The reason this problem becomes worse with age is metabolic health, i.e. liver health. The worse off your liver is, the less able it is in detoxing substances like homocysteine. Some fasting and a low-carb diet will reverse this, or you could simply take some TMG. TMG will promote detoxification of homocysteine, and this potential problem will simply go away. Or ideally, you could do all of the above and be absolutely sure it's under control. Although it doesn't replace any expensive supplements per se, vinegar deserves an honorable mention. It helps with everything from depression to high blood pressure and obesity, and is also quite cheap. Definitely something everyone should consider, whether you're on a budget or not. Of the supplements I mentioned today, currently I take taurine 6 grams, glycine 6 grams, betaine/TMG 2 grams, cysteine 2 grams, niacin 250 milligrams, and apple cider vinegar 50 milliliters. But you should adjust this according to your own needs and consult a doctor as needed. You can't make a 90-year-old into a 20-year-old, not yet anyway. But if you do some fasting and add in these supplements, You will likely feel better than you did when you were 20 years old.
It's a Festivus miracle!
Dinner's ready!
Let's begin.